Hello, this is John Voss for another exciting adventure of Java. This is your ninth lecture. Um, if we look at the syllabus, we can see where we're at this point. It's the week of the 17th of March, and we're on methods. So last week we went over loops and files, and programming assignment 3 was assigned. There seemed to be a little bit of confusion over programming 3. So I just want to make it clear that you are supposed to use the scanner class for programming 3. If we look at the program description here, you'll notice that it will say to write a program that asks the user to enter the day's sales. The program should write a bar chart to file where the chart is comparing each store's sales. You'll use asterisks to indicate each $100 of sales. For an example, from the command line. So it says command line right here. So that's pretty clear that you should be using the scanner class, all right, not the GUI input such as JOption pane. So I thought it was clear, but there was a little bit of confusion. So I wanted to make it abundantly clear what exactly was going on here, because it does say from the command line. All right. So if there are any questions with that, please feel free to post it to the discussion board or send me an email. But please ask pointed and actual, very clear questions, so I know exactly what you're having trouble with. If you send something to me like fix this code or what's going on or something, I want to know at least that you're running it, testing it, and that you see something's wrong and you're not quite sure where it is. That's obviously great. If you don't know exactly what's going on, that's fine. But you need to show that you're asking the appropriate question, because I've gotten a few students actually that have asked. They've made statements or asked kind of very broad questions. It helps a lot if you narrow it down for me or let me know what exactly you're having a struggle with. So, all right. So today we're going into methods. It's a relatively short chapter, but it's a very interesting and powerful chapter as well. So it's very, very useful. So chapter 5 is methods. We'll discuss, I'll introduce methods, and we'll talk about passing arguments to a method, a little more on local variables, returning value from a method, and problem solving with methods. So why would you want to write methods to begin with? Methods are commonly used to break a problem down into small, manageable pieces. This is a technique called divide and conquer. The General Napoleon Bonaparte used it against many different armies, most notably the Russian army, which was larger than the army he sent in. So he basically caused them to divide, and then he overwhelmed each little portion of it, of the opposing army, and was able to win. So he divided them and then conquered. That's exactly what you're going to do with methods. So methods simplify programs. If a specific task is performed in several different places in a program, the method can be written once to perform that task and then be executed anytime it's needed. This is called code reuse. It's a very good software engineering technique. There are different types of methods. There are two major categories that we'll discuss. This is based on the data type that is returned, okay, or the return type. There are void methods, and then there are value returning methods. Now, void methods are in a league of their own. It's just a method that performs a task and then terminates. Value returning methods, which we'll see a little bit later, actually return a value to the caller. So we'll start at void. The void method simply returns or simply performs a task, and then all it does is terminate. So it just returns control back to whatever the calling method was. It does not return a value. Value returning method not only performs the task, but also sends a value back to the code that called it. For example, I could declare or utilize a number here, a variable. This one's an integer, and then you've seen this method before. It's the integer.parseInt method. You pass it a string. We saw this when we took when you take string input from either the scanner or the JOption pane input dialog box. So when you take in the string here, this integer class, the parseInt method is called on this string, and this value, or this call right here, returns an integer. So that means that this whole statement here is actually and ultimately replaced by the integer equivalent of whatever the string was it passed in. So in this case, 700. So the actual value 700 as an integer will be put into int number. To create a method, you have to write what's called a definition. The definition of a method consists of a header and a body. The header, which appears at the beginning of the method definition, lists several important things about the method, including the method's name. The method body is the collection of statements that are performed when the method is executed. So here's a general example here. Well, this is a more specific example, but it's got the locations labeled here. The header is the part up at the top, such as you've got the access modifier here, public, static, void, and then display message. So this is the return type. We know that it's a void, so that means it'll perform an action and then terminate. Static means that this method belongs to the class and not a specific instance of the class. We'll talk a little bit about that in later chapters. And then public basically means that the outside world, any code outside of our class, can access this method. So the only thing this one does is it prints hello to the console. So let's focus in on the header for a second here. You've got public static. These are the method modifiers, public static. The return type void, method name or method identifiers, display message, and then you've got parentheses. The parentheses in this case do not contain any parameters, which we'll get to later, but in some cases they do have data going in here in between the parentheses. So a little bit about method, the method header. First, the method modifiers. Public means that the method is publicly available to any code outside the class. Static means that the method belongs to a class, not a specific object or instance of a class. The return type void, or the data type from the value returning method. So in this case, it's a void, so it does not return a value. The method name is the name that's descriptive of what the method does. That's usually a good rule of thumb. You could call it M1 or M2, but those would be very, very bad names. Just like variables, you want to give methods good names. Parentheses contain nothing or a list of one or more variable declarations if the method is capable of receiving arguments. Okay, so you can, when you want to send data into a method, you use what are called parameters, or when you actually send the value, it's called an argument. So we'll get more specific with that later. One thing to note at this point is that in object-oriented programming, which we've talked about before and even had, I believe, a question on your test about it, the object-oriented programming, the three pillars are encapsulation, inheritance, and polymorphism. One of the major concepts in object-oriented programming is that we want to take a class and we're giving it behaviors and data about the class. So the data would be like variables. Okay, the public variables, private variables, local variables, these are all pieces of data in the class. The method are the behaviors. Methods are behaviors. They're things that the class does, not things that the class is. Okay, there's a distinction. But they all have to have valid Java identifiers. So calling a method, also called invoking the method, so we call this a method call or a method invocation. The method executes when it's called. So you can define a method, but then never call it, and it'll never be used. The main method, which we've written over and over and over again, is automatically called when a program starts. But other methods are executed by method call statements. So for example, if you just type display message, like the one we just did, display message, notice the method modifiers and the void return type are not written in the method call. They're only written in the header. So in the header you have public static void, but when you actually call it, you only call the method name and then names of any variables or values passed in, not the data types, none of that. So you don't bother with the return type or the method modifiers. Okay, so we'll do an example. One example we'll get done with here, work on is simple method.java. So I'm going to create a new project, new Java project, lecture 9. Oh, that sucked. I'm going to delete that. That wasn't good. Try it again. I hit enter too fast. Okay, so Java project, lecture 9 examples. Finish. All right, so we have an empty source file. I'm going to add a class by right-clicking and going to new class. This particular class is going to be called simple method. All right. So inside of simple method, I'm going to put public static void main, string args, string array. All right. And then I'm also going to, in this one, define another method. This one will be static too, because we need it to be static to call it directly from main. So it's called display message, and all it's going to do is call a print line statement. So hello from display message. All right, all it does. Now, if I were to run it right now, this would do nothing. Okay, this would actually not, nothing would be printed to the console at all. So inside of main, I'll say before display message in main, we'll put another print line after display message in main. And then in between them, I'm going to make an actual call to display message. Note that I do not have any of the access specifiers, access modifiers, or the return type in front of it. So let's run this and see what happens. If I run it and you look near the bottom, you'll see that it says before display message in main, hello from display message, and then after display message in main. So when it called the method gets control, and then after it gets control, in this case the method just calls another method, in this case print line, with the argument hello from display message. Okay, so then that's printed to the console. So the next thing that I'm going to look at is we're going to make another example with method calls. In this package, I'm going to create a class. We're going to call this one a loop call. So we've got loopcall.java, public static void main, string args, and then we've got another method, public static void display message again. We can obviously call it whatever we want. Say in display message. So pretty much the same thing as before. But in main, we're going to do this. We're going to say print line, hello from main, system.out.print. Back in main before the end. Now inside of here, for int I equals 0, I less than 5, plus, and I'm going to call display message. So I I'm actually calling a method from inside of this loop, so we're combining a couple of the constructs that we've learned before. So if I press play, you'll notice that down at the bottom in the output you'll have hello from main, and then 1, 2, 3, 4, 5 in display messages. And then at the bottom, back in main before the end. So this is pretty much what we expect. Even if we were to just put the print line statement here directly, it would be calling a method. But this time we've defined our own method and decided to call it that way. Now obviously this method could do a whole lot more, but we just decided for demonstration purposes, let's just put a print line statement. A method should always be documented by writing comments that appear just before the method's definition. Comments should be brief, provide a brief explanation of the method's purpose. The documentation comments, or Java doc comments, begin with / and end with a /. Okay, so if I wanted this to be prepared for a Java doc comment, I could do that. So I could say hi there. I could say this is display message void, and then you can describe what it does. Prints a message to the console. So you could choose multiple ways to document this. So that's one way. What about passing arguments to a method? Well, passing arguments to a method is also another very, very useful thing to do. Instead of just having the method do something, what if we need to send the method some sort of data? What if we need to give the method some sort of data? Now you've seen and you've been dealing with methods that take arguments all along. For example, system.out.println, this does take an argument. This right here, hello, string is an argument. Println takes this string argument. Then you have a value returning method as opposed to the void println method. You have a value returning method, integer.parseInt. It takes an argument as well, str. So when you pass some sort of string in there, it parses it if it can, and then returns the number. So the data type of an argument in a method call must correspond to the variable declaration in the parentheses of the method declaration. The parameter is the variable that holds the value being passed into a method. By using parameter variables in your method declarations, you can design your own methods that accept data this way. So it's pretty straightforward. What we're going to do now is I'm going to create another. Let's do it this way. I'm going to create another class here. We're just going to call it argTest. So the thing that we're going to do here is I'm going to put public static void main string array args. Okay. This does main even takes a set of arguments, and you'll notice. And we'll say public static void. Say hi. And we're going to pass it a string of name. So it's going to do system.out.print, system.out.println, say hello. Alright, so this does take, we just defined a method, and this is the method definition here. Public static void, so public and static access modifiers void return type, so it doesn't return a value. Say hi is the method's name, and then we pass it a value that's a string. Now, what will be passed, what this variable does is whatever the user of this class or the client of this method, the client of this method passes in, that data will go into this variable called a parameter. When we're talking about the method definition or declaration right here, this is called a parameter. When we actually pass a value into it, it's called an argument. So in main, if I call say hi, and I let's say hi, and I call it on the parameter John, I can run it, and it'll say hello, John. So what we have here is we have John, the string literal being passed in is called the argument, because it's an actual value we're sending into the method. In the method header, this string name is actually kind of like a local variable to this method. If I try to access name out here, it'll be an error. It won't know what name is. Name's never been declared because they're not in the same scope. Okay? So when I call say hi, this John gets stored in name, which is local to this method. This is, again, over here, it's called a parameter. This is an argument. And then this is called a parameter. Right? So this is a parameter also. So we would say that this is a parameterized method. For the display value example, you can, in the actual argument call, you can pass the value 5, or you could pass a variable that holds 5. In the definition, you have display value int num. The argument 5 is copied into the parameter num. So when the method gets called, it will put the value that was passed in into num, and then make use of num in whatever way it needs to, whatever way the method specifies. So argument and parameter data type compatibility. This is very, very important because you will get errors if you try to do narrowing conversions. In other words, if you try to do a conversion that you could lose data in, then you're going to have a potential problem. It's going to be an error. So display value, we saw earlier, takes an int. When you pass the argument to the method, you have to make sure that the argument's data type is compatible with the parameter variable's data type, or just parameters data type. Java will automatically perform widening conversions. That means if you don't lose data, Java will automatically do it for you. A narrowing conversion will always cause a compiler error. Okay? If you try to do a narrowing conversion, you have to actually cast it explicitly to the correct data type, or it won't work. The widening conversion is if we try to pass, for example, an int into a method that takes a double, or a float into a method that takes a double, or a short into a method that takes an int. Those are all smaller types that we're passing in to the method that takes a larger type. The opposite is not true, though. If I try to pass a double in where I'm supposed to be passing an int, there could be loss of data. So if there's any potential loss of data, that's called a narrowing conversion. All right? It narrows down. So that means you could be losing data. So that's actually a compiler error in Java. What about multiple arguments? Can I pass more than one argument? You actually can. Multiple arguments are used quite frequently. For example, this one here, the call looks like this. Notice the arguments are only separated by commas. And then public static void show sum, double num1, double num2. These will correspond. And notice this is performing a widening conversion, because these are integers, technically, what you're passing in here. And it's storing them in a double. Now, if this was backwards and you had these as integers, and then you made this 10.6, that would be an error, because it would lose data, and that would be a narrowing conversion. So what happens in this method? We have show sum. It has double num1 and double num2. Inside of the method, you declare a local variable called sum of type double, and then you set it equal to the two values that were passed in, and then all you do is print out the sum is, and then the value of the sum. In Java, all arguments of the primitive data types are passed by value. Okay, integers, floats, doubles, etc. This means that only a copy of an argument's value is passed into a parameter variable. The method's parameters variables are separate and distinct from the arguments that are listed inside the parentheses of a method call. If the parameter variable is changed inside the method, it has no effect on the original argument. Okay, that's the key right there. If the parameter variable is changed inside the method, it has no effect on the original argument. So let's do another example. This time I'm going to do an example called pass by value. And for pass by value, I'm going to create my main. Okay. I'm also going to create a method down here called change_me. So I'm changing the value. I'll take the parameter that passed in, set it to 0, then say system.out.println. Now the value is my value. Okay. So inside of main, I'm going to create a number. I'm going to set it equal to 99. I'm going to say system.out.println. Number is number. Then I'm going to make a call to change_me, pass it the number, and system.out.println. I'm going to say number is now. Okay. So what do we expect here? Well, we declare the number as int number and then set it to value 99. And then we say system.out.println number is, and that should print out 99 here. Then we call change_me. So that gives control of the code to this method right here. So it says I'm changing the value. It sets the value, which is the parameter that's passed in, number. Coming into the method, it's 99. Then it says my value is 0, prints out as 0, but does it change number? Does it actually change number from the calling method? That's what we find out on this line. So let's run it. If you look at the output near the bottom, you'll note that it says number's 99. I'm changing the value 0, so that's inside the method. And when it returns control back to the calling method, in this case main, you'll note it now says number is now 99. Okay? It's because it does not change, does not modify the argument. Passing object references to a method. Recall that a class type variable does not hold the actual data item associated with, but it holds the memory address of the object. A variable associated with an object is called a reference variable. Okay, I'll say that again. A variable associated with an object is called a reference variable. You should commit that to memory. When an object such as a string is passed as an argument, it's actually a reference to the object that is passed. So the string is a class that the Java developers have given to us and allowed us to use. It is not a primitive data type, it's an actual class. So when an object such as this string is passed as an argument, it's actually a reference to the object that's passed. Passing a reference as an argument. So let's say we have this string str, this name. Both variables reference the same object. So let's say address points to this thing that says Warren. The address of the object is copied into the string parameter. So when you pass it in, it actually passes the address. So it'll say str is something, characters long, and then if you try to set it here, str equals Joe, what does that do? Well, it's a little different for strings. Most objects it would modify them. If you change them in the method, it changes them in general. But in Java, the strings are immutable, which means that they cannot be changed. When the line str is executed, it cannot change an immutable object, so it creates a new object. So this is what you get. When you say str equals Joe, it's implicitly calling new, and it's actually creating another reference in memory. So we'll say Joe. The string variable holds the address of a different string object. If you're using Java docs and you want to provide a description of each parameter in your documentation, you can document them by using the @param tag. So @param, param under name, description. So if I'm down here, I could say my Java doc, it automatically in Eclipse adds param and then the name of the parameter. I could say an integer that is printed out and changed. Okay. So anytime you hover over change me, you'll notice that automatically I can see the result of the Java doc here is that my value, an integer that is printed out and changed. So it's pretty useful. These Java docs allow you to make code more readable and also help with the general documentation, so that you can actually help other readers and other programmers know what you were doing if you give them code. This is how a lot of open source projects survive, is because of good documentation. So what about more about local variables? What do we know about these local variables? This is section 5.3. So for local variables declared inside a method and is not accessible to statements outside the method. So in here, in change me, if I were to make an integer a down in here and do something with it, blah, 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 no other method has access to this. And the variable is only going to be alive as long as this method's alive. So when the method returns control, that variable will be destroyed. Maybe it was used as an intermediate value or something else, or maybe it was written to file, but as far as being in memory, it will be destroyed after the method's done calling. So different methods can have local variables with the same names because the methods cannot see each other's local variables. So if I had a method A with a variable named snow in inches, and then I had a method called B, and it had another variable called snow in inches, they would not conflict. It would be totally fine to have two methods with the same variable name as long as they were local. A method's local variables exist only while the method is executing. When the method ends, the local variables and parameter variables are destroyed and any values stored are lost. Again, just to make sure we know the distinction, this is a parameter, or a parameter variable, int my value in this case. This is a local variable, is declared in the body. The things that are declared with the header are the parameter variables. Now, if I wanted multiple parameters, I would put a comma and then separate them. They do not all have to be the same type. They could, they don't have to. They have to be, and there could be any number of parameters, as long as the memory allows. A method's local variables, again, exist only while the method is executing. So if we go back here, when I have a declared here and set to a value 0, as soon as this method's done, that memory for that integer a is returned back to the operating system, or the program in this case. Local variables are not automatically initialized with a default value and must be given a value before they can be used. What about returning a value from a method? So at the very beginning, we talked about the two different major categories of methods in Java. You've got void methods, which just perform a task and don't return a value. And now you've got also value returning methods. So again, we've seen examples such as integer.parseInt of the value returning methods. We've also seen examples of void methods like the system.out.println. So for this right here, the string 700 is passed into the parseInt method as a parameter, and then the int value 700 is returned. Now what it means to be returned is that ultimately this call right here, integer.parseInt of 700, can be thought of as replacing itself with the value it returns. So whatever you say after a return statement is what value will be put in. So let's say we decide we want to make a value returning method. In this case, they do a sum. It's a pretty trivial example here, but it gets the point home. Public static int sum, and it takes an int num1 and int num2. Again, this is not a void method anymore. This is an int method, so that means it's value returning. It returns a value. So the return type's int. The return statement causes the method to end execution, and it returns a value back to the statement that called it. So it usually goes at the end. In this example, they declared a local variable, and they say result equals num1 plus num2, and then they return whatever the value is in result. Now, this variable result still gets destroyed once this method is done executing. but the value could be captured in the method that called this. So if main calls sum on 2 and 3, 2 and 3 will get added, stored in result, that's 5. When it says return 5, whatever you're capturing it with, variable in main, it will obtain the value 5. Okay, to call a value returning method, such as the example above, let's say I have an integer called total. I'd say total equals sum, value 1, comma, value 2. Let's say I pass 20 and 40 to it, goes into the method here, adds them up to 60, and then returns a 60. That means total will obtain 60. Let's do another example. I'm going to call this class, let's say, value returning. That's better. Public static void main value returning. Public static int square. It's going to be passed. I'm going to pass a value x. And all I'm going to do here, I'm going to say int sq equals x times x, return sq. Okay, this is system.out.print line. The square of 4 is, I'm going to call square on the value 4. And I'm going to copy and paste this line right here a couple times. I'm going to pass it, I'm going to do it on 5 and 6. 5 and 6. Alright, so if I run it, you'll notice at the bottom it says the square of 4 is 16, square of 5 is 25, square of 6 is 36. Exactly what we expect. So in this case, I'm using the value returning method, integer returning method, value returning method square, in line as part of a parameter that ultimately will become a string for the printline method. Now, I could have also done something like this. So I could say int result, let's say result 12 equals square of 12. I could do this. The square of 12 is square, they call it 12. And we'll see what this does. So in this case, it does exactly the same thing. It says the square of 12 is, and it shows you the result. Oops, I actually need to do that. Result 12. I'll do that also. I'm going to run it. It does the exact same thing. Okay. So anywhere you could use a regular value, you can call a method as well that returns the value that's compatible. So you can call a method on a method on a method. We could do something really creative here. I could say int crazy result equals square of the square of the square of 2. And since each of these returns an integer, ultimately what we get is the integer. The crazy result, so the crazy result equals crazy result. Alright. So I run it, and I get the crazy result is 256. Well, think about why that is. Well, in order to make this work, this innermost square must be called, because square here is expecting value. It can't do it until that one's done, and this one can't do it until that one's done. So square of 2 returns a 4, square on 4 returns a 16, and then square on 16 returns a 256. All right, pretty straightforward, pretty decent. Another way to write the square method right here, another thing we could do here is instead of even using this intermediate variable here, we could also, I'm just going to comment out these for now, we can also just do this, return x times x. You don't even need the intermediate variable there. We're going to run it, we'll see that the results are identical. Okay. You can use the return tag in documentation. Provide a description of the return value. Your documentation comments by using the return tag. So, if I have this, I can say, so it already gives you some stuff. param x, the integer to be squared, returns the square of x. Or since it's a comment, you can even do something like that, x squared. What about returning a Boolean value? Sometimes we need to write methods to test arguments for validity and then return true or false based on those arguments. So public static Boolean, this is our data type Boolean, is valid, takes a number, and then what they're doing here is they're making a local variable status. If the number is, essentially what this is saying is between 1 and 100 inclusively, you set the status to true, otherwise set it to false, and then just return the status. So the calling code might look like this. You could do this. You could say, should be a lowercase f, by the way. You could set the value as 20. Now, is that a valid value? Yes, it is. So now you call is valid. Now, what does is valid return? A Boolean. So that's why it is okay to use it inside the parentheses of an if statement, because this has to be a condition or something that returns something else that returns true. It has to return true or false. It has to return a Boolean value. So you call is valid on value, pass the 20 in. Since that falls within the range, it sets status to true and then skips the else and then returns true. So since this returns true, we print out this. If the value was 105 or a 0 or a -6, it would go to the else part, which says values out of range. What about returning a reference to a string object? You have the local variable name holds the reference to the object. The return statement sends a copy of the reference back to the call statement, and it is stored in customer name. So I have customer name here. I have the method's full name, returns a string, John, Martin. All it's doing is concatenating, or some of you might call adding the strings, but really the word you should be using is concatenating. A space in between them, concatenates the first name and the last name, and then just returns the full string as a name. Since this is a value returning function or method, value returning method, it replaces itself. Essentially, you can think of it as replacing itself as, with the return, or with return value down here, name. So in this case, it's going to be John space Martin as one string. That will be stored in customer name. So how would we solve problems with a method? Well, a large complex problem can be solved a piece at a time by methods. The process of breaking a problem down into smaller pieces is called functional decomposition. As an exercise for you, just to become familiar, I want you guys to look at sales report, which is, one second, I'll find it. Okay. The sales report is on page, there we go, page 307. Right, I had a number down, but it was wrong. Okay, so it's on page 307, and this one actually does file I/O as well. So what I want you guys to do is I want you to spend some time working with this. You're not going to turn it in, obviously, but it's for your own exercise. The code's right in front of you. It's just about 2.5 pages worth of code. Just get used to typing and copying code and looking at it and try to understand it and see what it's doing. Make slight modifications if you want, but also make sure that you create a file that has 30 sales figures in it as well. So 30 days of sales amounts. So however that works. All right. So also another note is if you call methods that throw exceptions, the sales report example, in main, we throw the I/O exception because whenever you use something that could potentially throw an exception, you have to either throw it or take care of it yourself. Since we haven't learned exception handling yet, we're going to learn it It's learned in a later chapter in the book. All the methods that use the scanner to open the file have to throw or handle this exception. So since we don't know how to handle it, you're going to just throw it. So that basically you're passing the buck onto something else. So terminate and then throw the exception. But you have to throw it or handle it, because if you don't, that would be a Java compiler error. So for now, you just understand that Java requires any method that interacts with an external entity such as a file system to either throw an exception to be handled elsewhere in your application, or to handle the exception locally. So we'll learn about exception handling in Chapter 12. It's try-catch statements. That's how we actually handle them. They're not very difficult, but for right now, just to keep our minds cleared and be know what we're doing without having to have any unnecessary complications, we'll just work with it that way. So, couple things just as a review. You should be familiar with, okay, how do I define a method? And you have to be able to define a method as either a void method, know what that means. You should also know how to pass arguments to the method now, and also how to define a return or a value returning method. And just as a note, a void method or a value returning method could take one or zero or more parameters. It doesn't have to be one or the other in order to take a parameter. You can pass any parameters you want that are anything that can count as a parameter can be passed. Now, in the actual header of a method, such as this right here, the header of the method again, this is called the parameter. Num is the parameter, and then when you actually call the method from another method, such as main, that's called the argument. Okay, so the actual value or variable passed in here, this could be a variable too, we pass in, containing a value, is called the argument. The thing that is local to the method is the temporary memory here in num. It acts kind of like a local variable. That is called the parameter. Now, there are different sets of terminology. Sometimes you'll hear some people call the argument the actual parameter, and hear them call the parameter the formal parameter. And sometimes you'll hear all kinds of a mixed basket of terminology. But it seems to be more standard that you call the value passed in the argument, and then the variable local to the method the parameter. So some literature uses them interchangeably, so just be aware of that when you're reading, but be very familiar with the differences, so you can be more educated on those topics. And questions like this could very well end up on job entrance exams also. So if you take a programming exam to get into a particular job, they might ask you questions like this. Okay, what's the difference between a parameter and an argument? We should be able to elaborate and explain what the difference is, okay, or identify a parameter versus an argument. Notice if this was a variable, though, you would not put the int or anything else in front of it. You would just put the value or the variable name. So, all right, that's a pretty short lecture today. If you have any questions, please feel free to message one another, or post stuff on the discussion board, or message one another asking for assistance, ask myself for assistance. I do recommend highly, don't post your entire code for your assignments. That's kind of borderline cheating, so just don't do that. If you need assistance, the only person you can really send all of your code to without it really being kind of questionable is me. So if you do have a direct question about all of your code as a whole, send me the code anyway. Unless I specifically ask for it in context on the discussion board, it's just not a good idea. So just I'm pretty lenient on that, because I know most of you are trying very hard and you're trying to learn. But if it becomes, you post the code and say what's wrong, and you don't ask a very, very specific question, then I don't know what you're really thinking, or maybe what you're struggling with specifically. So it's hard to address problems and it's hard to learn from one another or help each other unless we know exactly what the issues are that we're dealing with. So I could do the program for all of you and then post the answer, but that's not going to be how you learn. Usually we learn better through struggle. So I'm not going to take all the struggle out, but if you do have troubles, feel more than free to ask me. Okay, feel free to email me, but make sure you're asking questions, not just making statements like "I need help" or "This is this isn't working. Why isn't it working?" Things like that. You have to say, "What is it doing? What isn't it doing? This is the error I'm getting." Just be a little specific and think through the process yourself. I've had many students tell me that they started to do that and then they figured it out themselves really quick because it dawned on them after they started thinking about what the problem was. They didn't even need to email me or post to the discussion board because it dawned on them how they were to do the problem. So, all right, if you need any help, just feel free to contact me or visit me during office hours. I'm here today, and I'm here a little bit on Tuesdays or Thursdays. Just check the syllabus for the best office hours. If you plan on coming and visiting me, please let me know though ahead of time so I ensure that I'm here during the regular hours and everything. So just let me know. Thank you, and have a great day.